Okay, so that we wrote as integration of above three equations produced Jacobi's integral, which we wrote as x dot square plus y dot square plus z dot square is equal to x square plus y square plus 2 1 minus mu star and the left hand side here this is nothing but v square. So, the same thing we wrote as v square x square y and plus 2 1 minus mu star by r 1 plus by r 2 minus c, and this can be written as 2 u minus c is equal to 5 minus c, where u is equal to 1 by 2 times x square plus y square plus 1 minus mu star by r 1 plus mu star by r 2. Okay. So, here the phi which is appearing. So, phi we wrote as a function of x y z, and for v equal to 0, okay, phi which is a function of x y and z. So, this describes the equation of a surface. So, we will keep discussing about these things, expand it further. So, what we were discussing about the librational points and the or the equilibrium points, which are also called the Lagrange points. So, librational points or the Lagrange points, they arise once we set x double dot y double dot and z double dot equal to 0 and x dot y dot z dot equal to 0, and substitute into these equations, and resulting equations they provide us the librational points. So, we need to solve them. So, also I stated that the librational point it is nothing but the double points. So, double points they can be defined as if a curve is given. So, this curve may intersect itself in a point. So, at that point at that point we can have two tangents. So, if this curve is defined by f x y. So, dou f x dou f by dou x equal to 0 and dou f by dou y equal to 0, this gives the double points. Okay. So, if we do the same operation on this equation, okay. So we have the Jacobi's integral available. So, we differentiate the Jacobi's integral or the function phi is equal to c is available to us. So, we can work with this and we can prove this. So, phi equal to c. So, here we can write it as this v square is equal to phi minus c. Okay. So, with this equation it is possible to work out using this partial differential and find out the librational points, or either you directly use the equation which we have developed earlier and set into this the x double dot y double dot x dot y dot and z double dot equal to 0. Of course, here z dot is not present in this equation, but this the equilibrium point also refers to the x dot y dot equal to. So, we have the x double dot y double dot z double dot equal to 0 and x dot y dot z dot equal to 0. This gives us the equilibrium